As you heard, my name is Michal Szymański. I would like to present you briefly some topics related to the airtightness of buildings in our country, in Poland. At the beginning, a few words about Poland. The population is about 38.5 million people. And for the building sector, it is very important that Poland still maintains economic growth despite the global financial crisis. Geographically, we have meteorologically, we have 5 winter design conditions regions, but the differences among them are rather small. It is about -24 to -16 Celsius degrees in wintertime and maximum +30 Celsius degrees in summer. So we can say we're rather cold than mild climate. We are from Poznan, that's the western part of Poland. The city has about 600,000 citizens. We represent Poznan University of Technology, which is one of the biggest Polish technical universities with more than 20,000 students. We work in the Institute of Environmental Engineering. Our staff took part in the IEA Energy Conservation in Buildings and Community Systems, that's Annex 36, in the years 1999 to 2003. And also Polish EPBD calculation methodology was developed in 2008 in our institute. We carry out basic and applied research in the areas of low energy buildings, buildings of tightness, heat and mass transfer in HVAC systems, modeling and optimization of air conditioning, fluid load measurements, calculations of energy performance of buildings and building components, and also fluid mechanics. Airtightness measurements which we conduct is often found by Passive House Center, which is a part of the Institute of Environmental Engineering. It's co-funded by Polish Passive House Institute. The most important tasks of the center are courses, trainings, energy performances, calculations, and measurements. Although we do commercial tests, indeed we are not a typical testing company. Airtightness tests are only one of many other activities we undertake. In Poland till 2008 we had no special requirements, which you could observe in a table presented by Rémi. I mean requirements for airtightness of whole envelopes. Since then, together with EPBD implementation, new building codes were set. Measurements at the moment are not required, they are only advised. But the N50 values are required. That means that no one has to measure airtightness of the building, but if someone measures it, the N50 value should be less than 1.5 air changes per hour for buildings with mechanical ventilation and 3.0 air changes per hour with natural ventilation. Building codes which are planned to be published in 2014 will not change the N50 limits. It will make a standard EN 13829 a reference norm for airtightness testing. But a step backwards is that the N50 values will be only advised, no longer required as it is today. There are some other guidelines, of course, concerning building airtightness in practice. One of them are the passive house standard. The number of passive houses in Poland is very low at the moment, no more than several dozen, and it is growing very slowly. This year, the National Fund for Environmental Protection and Water Management introduced a new program to promote low energy buildings. And one of the obligatory requirements for gaining subsidies in this program is to test the building airtightness, and N50 should be less than 0.6 or 1.0, depending on energy standard of the building. There are two standards, 15 and 40 kilowatt hours per square meter a year. Although there is a statement in this fund rules that airtightness examinator may be any company which use appropriate instrumentation. And now a few words about testing companies. There is no companies association in Poland, and there is no real communication between these companies. We have no requirements for testers stated. They very often have no competencies, knowledge and experience. It often leads to failures during the tests and wrong N50 values as a result. And the worst situation is with large buildings where is absolutely no experience at the moment. A good example of such a situation is airtightness test made in large aqua park in Poznan, in our city. We were asked by investors to observe the measurements done by the company with complete lack of knowledge in the field of large buildings testing. There were important measurement mistakes done, like, for example, transzonal uncontrolled flows during the test because of no simultaneous pressurization of adjacent zones. Other words, flow measurement was performed with unknown accuracy. The air handling unit manufacturer didn't provide any reliable data in this matter. Testing team was not familiar with the building and its design. Tests were conducted with several ventilation system operating, and the system were not involved in the test. And we found a big differences in N50 result, like for example at under pressure 1.9 changes per hour and 3.0 at overpressure. In Poland, the most popular blower door test unit is Minneapolis blower door. We have no large funds at the moment, so there are some attempts to measure air tightness with the use of air handling units. The biggest problem with such tests is that we do not know the accuracy of the flow measurement on air handling units. We try to ask some manufacturers, and each time we get no clear answer in this field. Here we can see some examples of single-family houses airtightness test results. Most of single-family buildings have masonry brick walls in Poland, and timber construction are rather rare. In the first row, there are some old buildings which were recently retrofitted, and the N50 values differ from each other rather high. In the next row, in the middle, there are some examples of new buildings, and then 50 in most cases are less than 3, even less than 2 air changes per hour. In the bottom row, there are 2 low-energy buildings with special concern to air tightness. The left one is retrofitted timber construction building, and the right one is masonry brick wall construction. Values are less or close to 0.6, so that's the demand for passive house. At the end, 2 examples of large buildings or tightness tests we conducted last 2 years. First one is placed in Szczecin, that's the northwest part of Poland. Quite good result, 0.49. And the second one on the right-hand side is our Poznan University of Technology Mechatronics, Biomechanics, and Nano-Engineering R&D Center, just built with a special concern to air tightness. It was not intended to build a passive building. These have rather high ventilation air rates and a lot of laboratories. And the N50 is very good, as you can see, 0.3. And the energy consumption is far better than it was required in tender specifications, so it's better than we have planned it. To sum up, we observe in Poland low level of awareness, experience, and knowledge among architects, designers, investors, contractors, and testing companies. At the moment, tightness measurements are voluntary, but N50 values are required, but next year will be only advised. The requirement are N50 value of 1.5 and 3.0 changes per hour, depending on the ventilation system, of course, mechanical and natural. The fields of interest of our works are synergy of air tightness and infrared thermography tests, determination of air tightness influence on building energy demand, multi-zone residential measurements, use of our handling units for testing, and of course durability of air tightness. Airtight envelopes. At the end, some plans of Passive House Center in cooperation with our Institute of Environmental Engineering. We are going to organize, as far as we know, the first in Poland scientific conference in the field of building airtightness. We want to try to establish a testing companies association, to lobby for setting requirements for testing companies, and to carry out training courses for new and existing companies. Thank you very much for your attention.